Hi everyone, my name is Connor Tullock and I'm a solutions engineer here at Nearmap. Today I'm going to be loading up a full Nearmap content stack within the InfraWorks environment. So that's going to be high resolution imagery, 3D terrain data, and then vector AI content. Once our data is loaded up, we're also going to look into concept planning, workflow, material takeoffs, and quantity estimates, as well as a 3D rendering workflow as well. So the first step to do this, we need to load up a new InfraWorks workspace, which I have here. I've named mine Boulder, since that's where our sample data set is coming from. And then we need to select our coordinate system as well, and then just give our model a minute to load up. Okay, so our InfraWorks environment has now been established, and we're ready to load up our Nearmap data. Before we get into that, let's run through each content type and how Nearmap produces that data set individually. So the first piece of data is actually a derivative product. This is our terrain data set, our digital elevation model. And we generate this after each flight by using photogrammetry techniques to establish 3D terrain information off of our source photos. This is going to help us establish that 3D base map. And then after that, we're going to overlay our high resolution 2.2 inch ground sampling distance data on top of it. That's going to give you your actual visual photo overlay on top of the terrain. The final data set that we're going to load is our vector AI. This is probably our most exciting content type that we have at the moment. And what we do here is we have a machine learning model that assists with ground feature recognition, and then we vectorize that content. And the reason that the vectorization is so important is because different programs like CAD and GIS software platforms can very easily then understand this information and load it into the digital world. So in the case of InfraWorks, this vector data is going to be loaded in a shapefile format, and it's going to help us directly create a lot of these really interesting InfraWorks 3D objects like buildings, trees, different ground cover types, roads, things like that. Okay, so let's get started by loading that 3D content up. So we want to go to our data connections and select raster, and then navigate over to our digital elevation model. This is going to be in a TIFF format. And then once we've established that data connection, we want to configure that data into a terrain as a type. And then close and refresh and give our model just a minute to load up here. Okay, so our elevation model has now loaded, and what we're looking at here is the triangulated surface of the existing terrain in our area of interest here. So you can see underlying boulder overshadowed by this mountain range in the distance there. So in order to gain the extra level of understanding of the area that we're looking at here, the next piece of content we need to load is a high resolution base map. So we load this very similarly. We go to our data sources and then establish a new raster connection here. And we want to load that as ground imagery this time instead of a terrain model. We're going to close and refresh that and give it a minute to just load all of that content and overlay it onto our terrain. Okay, so after just a few minutes, our high resolution image has now been draped over our terrain model that we previously loaded. If we just zoom in here, you can see how extremely high fidelity Nearmap's vertical imagery really is. We provide it at a 2.2 inch ground sampling distance resolution. Really lets you get the full context of what is going on in your site rather than just seeing that 3D data. If we go over here to this area of a little bit more of an elevation difference, you can really see how tight that triangulation is. You can see that the road has been clearly defined. You have the side slopes down that hill very clearly defined. And then looking at this wireframe, you can see the spacing between the different data points is extremely tight, giving you a very high degree of accuracy on your area that you're looking at. Okay, so this is our workspace as it stands now. We have our high resolution image draped on top of our terrain data, and next we're going to load our most exciting content type, our vector AI data. The reason that this is so exciting and has the potential to be such a massive game changer is because it's the next evolution in mapping and understanding and digitizing the world, right? The starting step of high resolution vertical imagery is great. can visually understand your environment and recognize what's going on in current conditions. Adding terrain data gives that third level, that 3D aspect to gain an additional level of understanding. And the vector AI takes that process that a human being does with their eyes and will process the imagery, automatically create points, lines, and polygons for common ground features that our clients may have value in. And this lets us very easily digitize that content and bring it into platforms like CAD and GIS. And we're going to demonstrate that here today in the InfraWorks environment. So the first object that I'm going to use is our roads layer, right? So we recognize this as asphalt and concrete. What I've done is I've done a little bit of post-processing. So our algorithm identifies edge of pavement, but I've gone ahead and done a little bit of scripting to identify the road center lines. And then we're going to digitize those by creating road layers in InfraWorks. So we load this content up by going to our directory here and loading a shapefile that identifies those road center lines. We want to make sure we load that content as the road InfraWorks layer. And then we want to select a style that fits with the environment that we already know what that road is going to look like. So here I just have a basic asphalt layer. And then we're going to drape that onto our existing terrain. Since these are existing roads, we want it to match the profile of the ground data that we've already loaded. All right, so after just a few minutes, our shapefile center lines have been converted into InfraWorks road objects. So these have loaded as planning roads on this asphalt default style that we selected. And as you can see, when we select it, we have a number of attributes that are built in. This is some of that utility that InfraWorks can offer, where it can help to automate a lot of the design process, loading design standards, making, assisting the engineer to make design decisions. So these are just existing roads. We're going to talk a little bit about how proposed roads work and how those can be created using the Nearmap content stack. But first, what we want to do in this particular case is convert these planning roads into component roads. A little bit of a workaround here is to use the traffic simulation tool. Again, really great tool to do those traffic analytics on existing and proposed roadways. And what it's going to do is, in order for that additional functionality to get built into the roads themselves, to run these traffic simulations, it is going to automatically ask you if you want to convert these planning roads into component roads. And that will give you profile access, horizontal constraint access, and a number of other quantity estimate items as well. So we're going to run this traffic simulation to convert all of the component roads. Again, keep in mind that there's a whole deep rabbit hole of traffic analysis that you can go down. We're not going to touch on that today. We're just going to use the utility of this conversion tool to get us over to our component roads for now. So all of our roads have now been converted. We have component roads for our entire existing road network here. If we click and select one of the segments, we can see that we have horizontal alignment information being displayed, our beginnings and ends of curves. And then we also have the ability to go into our profile viewer and see what the road profile is doing in that Y direction. So here it's really an approximation. It's simply draping on top of the existing terrain, but it can give you a good understanding of what sort of grades we're dealing with. And again, it's piggybacking on that accuracy of our 3D terrain model. There's a lot of utility built in here with some of these road tools. We're going to talk about quantity estimates and removal items and earth excavation at the very end of the video, but now we're going to just continue on loading up our AI data set and digitizing the city of Boulder here. So let's go into our shapefile and load up our next AI content here. So we're going to select our building layer next, our 3D buildings. So selecting that shapefile, we're then going to configure that vector file that we've loaded. And we're going to select the InfraWorks building object type. We're going to have a little bit of option input here for heights of building, extrusion, different style options. We're going to go with a random colorization option. Something to remember, these buildings can actually get highly accurate if we pair it with our other 3D types, such as our digital surface model, which will very accurately define roof heights. But for now, for this use case, we're just going to simply do extrusions, and that'll be good enough for us in this instance. Okay, so our 3D buildings have now loaded. Again, what we've done here is we've loaded our the Nearmap AI vector building footprint layer as a shapefile. This has defined the geometry in the plan view of all of these buildings, and then we have simply loaded them as building objects and extruded up from those building footprints that we've loaded. So this is giving a impression of the real world. It's not quite the perfect representation of these buildings, but it's going to get us pretty close. Again, we have much more accurate LOD2 building workflows that we've posted on our documentation that I also can link after the video. The digital surface model that we provide can help to very accurately model tops of buildings in addition to those building footprints and get much closer into the real representation of the world. For this use case though, this is going to be fine for us. It should just load that rendering of Boulder itself. We're also going to just go ahead and continue to move along here and load up a number of additional AI vector layers. The next one we're going to load is our tree layer, our medium vegetation layer. So this is defining all of the edges of these medium tree canopy, the limits of the canopy of medium trees. So what we're going to do here is a little bit of a different workflow where we take our shapefile and then we use some of the functionality of InfraWorks itself in this table setting to randomly distribute 3D tree models within the canopy layer and give that representation of what the trees are probably doing in those areas more or less. And it's going to really create a high quality rendering for us. So we're going to select our tree model that we want. I know that this is a pretty decent one. I've used it a number of times as well. Confirm our geolocation. We're going to drape the object on top of our terrain. And again, we're going to use this table setting for object spacing and object spacing variance to distribute these tree models within our workspace. So we're just going to give this a second to load up and then we'll jump right back in. All right, so as you can see, we have 3D tree objects now that have been distributed among our canopy envelopes, and this adds a nice extra piece of depth to our model. We have a lot of AI attributes. What I'm going to do is I want to avoid going through the loading process for each one. I'm going to do one additional one for a concrete slab ground layer. This is a coverage area. It's a pretty typical type of InfraWorks object that you load up, but there are a lot. We have things like power poles, power lines, solar panels, different roof attributes in terms of damage. We have cars, again, different types of ground coverage. All of these can be loaded. As long as it's vectorized content, it can be loaded within the InfraWorks environment. So let me jump ahead here to concrete slab. What we want to do is select that shape object. We want to move over to our configuration options and select the option for coverage area, and then select a good rule style for something that's going to represent that object well. So I think there's actually a direct concrete terrain type. So we're going to go with that one and then hit load and give it a second. Moving over to this aerial view, we can see that our concrete slab has been identified at the ground. We now have an InfraWorks object associated with it. We have our sidewalks. A lot of our driveways have been identified by the algorithm as being this material type. Again, adding that extra additional layer. All right, so that was just a handful of AI attributes that can be loaded as 3D objects within InfraWorks. Again, we have many, many more, and what I'm going to do is go ahead and go through that exercise here to load them on my own off camera, and we'll come back and show what the full 3D rendered Boulder scene looks like using only near map content, our high resolution imagery, our terrain data, and then that vector AI data to load up these InfraWorks 3D objects. After that, we're going to talk about a little bit more of the engineering side of this. How do we apply a lot of this content stack to more of a concept planning rather than a simple 3D rendering environment, looking at things like quantity takeoffs and earthwork analysis as well. So now I'm going to jump into that completed 3D rendering video and then move right on to concept level planning after that.